And the first speakers, these are a pair of speakers, Mr. Flöth and Mr. Pfeiffer, both I know for a long, long time, and they're still working on things which have been, I think we started already with the CIA 447 approach, I think 5 years ago or something like that.
And Holger, allow me to follow up on your words. We are constantly reinventing the wheel.
Okay, okay. So I hope you will not. Yeah, you're right. We do so, but we have more nice wheels maybe in the future. They will talk about that what is very special in automotive industry. These are special cars. These cars could be ambulances, police cars, and we have also somebody from the police here today in the audience, and we can use this in taxis. We can use this approach also in cars for handicapped drivers is not correct, I think. In America, yeah, I can't say this in Europe, but in US I should say disabled people. So, yeah. So to be politically correct, and they will focus on that what we have developed in CIA 447, in particular that what is regarding the testing of that. And I just hand over, I think first to Bernhard Flöth from Opel, still Opel? Still GM, but in the future, he already said that he may learn some French, maybe. I hand over, and then I think Olaf will follow up.
Mm-hmm. Okay. Good morning. I'm the lead engineer for electronics for conversions. Means police cars, taxi, emergency cars, but also big fleet sales. Unfortunately, I'm not allowed to do my planned presentation because of longer lasting release process in our company. But now I have the possibility to say thanks to the SIA because we come together 5 years ago. I think it's a little bit longer than 5 years, but I don't exactly remember it. And we found with the SIA the right organization to do a standardization which longer ago is really necessary, because for this special business and the small amount of cars, a standardization is really necessary to have a common development platform for the suppliers and also for the car companies. I remember not only the technical things, I'm in the standardization. It was not software, it was hardware. We sitting together to find a release plug in each OEM company, which is also able to got from the market. And it took really long to get this plug, but also this was one of the basics in the standardization. So really thanks to the SIA, it was the right platform to do the work, and I look forward for the new goals like cybersecurity, system safety, which will be included in our standard in the next time. Also one main thing for our business will be, we will start soon with the conformance testing for CIA 447, which is really important for us as car manufacturers, because this will increase the plug-and-play compatibility and will reduce our validation and system integration time. So I will now hand over to Olaf Pfeiffer. He will present one part which is necessary for the conformance testing.
Thank you, Bernhard. Okay. Yeah, as Bernhard introduced, there's quite a bit of testing, and also to follow up again on Holger's words, there's not only the conformance testing, we also have the interoperability testing. And that is really a challenge in this application, because by the books or by the standard, we are full plug-and-play compatible. And if you look back, CAN has been hot plug forever, but really, well, it's not enough to just plug something in. You need to know, what is it that I plugged in? What does it replace? And the CIA 447 variation of CANopen is one of the highest level plug-and-play support that we ever defined in CANopen. And it brings up a whole lot of new challenges for testing. And that's why I said we, of course, once in a while have to make the wheel a little rounder by reinventing it, because simply the test situations are new and different. And so I would like to just give you an example for one of these components. What is so challenging about the CIA 447 version? Well, for a start, this is an automotive application where devices wake up and sleep. And they can be constantly under power. So in sleep, one of the goals is to stay below a milliamp. Others say, oh, you have to go much lower below that. And the question is, when does a device go to sleep? Well, if a device does not find its required communication partners, one of the demands is, well, you have to go to sleep. And now imagine a test situation. You want to test a device. Hey, it constantly goes on sleep for you because you're not informing it that everything is in place to keep the network alive. So this is just one of the little pieces here. Another one is due to the comes from the plug-and-play requirement, is that CIA 447 is very dynamic. It uses something called the layer setting services. And those are used to assign devices dynamically a node ID. And a node ID is the #1 thing we need to communicate with a device, because in any CANopen communication, we need a node ID to say, hey, device number 5, what are you? What are you doing? And these IDs in 447 are dynamically assigned on every wake up, which means that after your second, third wake up, it could be that if one device started up a little slower, the node IDs changed. And suddenly, the taxameter you were talking to before had maybe node ID 5 before, suddenly has node number 7. And so these are the things you have to figure out and rescan the network, what's happening. And one of the latest enhancements we did to the standard is what we call the boarding complete option. There's literally an option where the main master, the gateway, can tell everyone boarding completed, no changes. Meaning we now have the same systems configuration as on the last wake up. So you don't need to start rescanning everything and find out who's it. And I'm not sure if we really used that wording, but it might very well be that it slipped some of the reviewers. I think it literally says boarding complete in the specification. So when it comes to the tools, what are the requirements for such an application? Well, as I mentioned earlier, we of course need to handle the wake up and sleep mechanisms. A test tool needs to be able to wake up the device, give it a node ID, and produce all the messages required to keep it alive. For even the simplest test tools, and here we are now talking to something you would use maybe at the end of a manufacturing line and say, I want to switch a few lights on and off and visually check by looking at it, did the lights go on and off, something like that. So we need to be able to have read and write accesses to parameters, an open scripting format. And one thing I learned working for this group, although it is somewhat automotive, it is really completely disconnected from the regular automotive purchasing world. So here we hear the word affordable a lot, because some of the manufacturers that produce roof bar lights or add-ons to Motorola microcontrollers, these are small companies who can't afford some of the high-end tools that typical automotive suppliers would require. So again, we needed to look out and see what can we use with existing tools to enhance them in a way that they are more usable for the purpose we need. And so the wheel we are reinventing today is called the concise device configuration file. That is something that has been around since the early days of CANopen. And for those of you not familiar with CANopen, just in short, this device configuration file is a method to store the configuration of a device. So a typical use case would be in an evening when you shut down your machineries and you want to make sure that the next morning you start where you left the machine right now. You read all the configurations and current status from all the devices, save it in configuration files, and the next morning load these files up again. And having that in mind, this concise device configuration file really is just a list of parameters. So really, it's the parameters for one device, nothing else. It's in CANopen terms, for those of you who are familiar with it, it means we know the index and the subindex, which tells us what kind of parameter is this, and then we have the data and the length of it. That's all that's in there. And if a tester or configurator uses the existing CDCF, it simply goes through this list of parameters, writes it to the device under test or device under configuration, or however you call it, write using the so-called SDO services, send the data, and you get the response, yep, data arrived, I stored it, and so on. So you just go through the entire list. So the CDCF is really just a list of write parameters that you send. Now, of course, for what we discussed earlier, there are quite a few shortcomings here because on the bottom line, we have no additional information of what to do with this file. If you just look at a single CDCF, you have no clue what's it for, which you can just only judge it by file name, maybe, where that should go. So you don't know, is it for a specific bit rate? Is it only for a specific node ID? And also, it only allows write accesses. So I could not do something like, hey, I want to read your identity first to verify if this is the right device I'm talking to. And there's no timing control. One of the things that can happen specifically in configuration is that the response time of a device is also depending on what you are writing. So if you're writing something to a device that maybe needs to be stored onto a file system, flash program, the response time can be much slower as if it's just some local variable. So also these things are all not part of the CDCF. Well, so we said we'll just take something that worked well in the past and extend it with the features we require for this testing. And one of the first things we said, okay, we also need a read command, preferably even a read verify, so that I can read a device's identity, maybe even down to the serial number if I want it, and only continue configuring it if I matched it up and know this is the device that I want. And so now one of these CDCF entries can also be a read request. The device returns it, and the player or the tester configurator executing the CDCF can now compare the response with the data expected and maybe decide to only continue if this data matches. Also, we needed some flow control. So what can we do here? One of the things I already mentioned is we require a configurable timeout because maybe some entries are much slower. So we need to be able to configure that. Maybe also just to have a delay and a fixed timing that we wait and give the time to give a device time to reboot. Maybe we issued something that internally it requires to do some restart or reconfiguration. So we need delays. And also we can wait for specific event or user interaction. The idea is what I said earlier. If at the end of the production light I want to check 5 lights, and then I cannot just send them one by one and ask the operator if he has seen all 5 lights blinking for 10 milliseconds or not. So literally we have a delay here, say user interaction, and now a user could say, okay, I've seen this working, click button, do next. And of course, other wait events that we could have is that we wait for a device to boot up, And maybe even we need to send it a network management master message and say, oh, you know what, please now to continue my test, go into operational mode or reset yourself, something like that. Then specifically for the 447 scenario, we said we also, of course, need to add a wake-up sequence, the node ID assignment, setting a node to operational, and these things. Now, the toughest question with reinventing the wheel is always the backward compatibility. We heard this morning already too. So how much backward compatible can we be when reinventing here now the extended CDCF? And we simply said, well, we don't want to change the file format at all, because even an existing player should somewhat be able to handle the file without immediately reporting an error. And so all the control commands that we added to it are added by using the index 0f0f, which is, we just picked one, an unused one. And typically in CANopen devices, this is never used. So specifically in a CDCF file, in a device, I think there would be no scenario that so far I could think of where somebody would really write this to a device. So, and we simply say, whenever this index is in the file, then this entry is not something we just blindly write to a device. No, it's a command. It now requires interpretation. And just with this little add-on, we can do all the things that I already mentioned. And here's just a little overview of the commands that we defined and are supported. So, for instance, there are even things in here like just adding visible strings for file information. So we just add an entry saying this visible string allows us to now really specify a text inside the file. Even if the file is later renamed, we can still identify it because it's now part of the file. We also offer an error text if a previous action has turned into an error. Hey, then we can output to the user a text message. And I want to not go over the entire list. You have this in your records. I'll just give you a little example on what the use cases are now. We can do what I said, the end of production line testing, where features are individually switched and somebody manually says and confirms it. If you have devices out there where you want to read out the error history and erase it, this is something we can do. And on the high-end side, we can do complete loading of configurations, or if a bootloader is supported, also bootloading support here, where often also for security reasons, loading an entire configuration table or even new code requires some very specific sequences to activate this mode. And here, one of the examples we have chosen is that there's a CANopen device where you can load a new configuration, but also to make sure that there's somebody thinking about what they are doing, what you have to do is you have to read the device's serial number and write it back to another location in the device, really as a way to authorize that you know what you're doing. And so we can also handle this with the extended CDCF by introducing a buffer. We read something, and the command allows it to be stored into a buffer, and then we write it to a different location. Now, how can somebody else start using it? Well, because we found this so essential and useful, we have this up on our webpage for free. There's, you can download a CANopen file player that takes one of CDCF files and simply plays it on the CAN port connected. And for editing it, to make editing easy, the input can be just plain comma-separated value files. And here's just one of example of such a file. Literally, you just load this file into the player and it will execute step by step. So just a quick summary. As I said before, at the beginning we have some file information and version. Then we run a wake up and LSS assignment. Then we have a delay. Then we assign a node ID to the device. Then we tell read the serial number. The next command is a read. Then we write it to a specific location. And in this case, those of you who are familiar with CANopen know that this will cause a device to reboot, because now it reboots into a specific loader mode, has a different node ID. We wait for the boot up and then send the table. And as you can see, we can just include entire file names into the entire system here. So one of the high-end uses of this is if you have a bootloader somewhere, this requires such an activation list, we can now send our customers dedicated files that just work on that one device, because we can double check, okay, this is their vendor ID, product code, revision and serial number, will only find this device, and so the user cannot really screw this up, because he has maybe 5, 6, 7, 10 completely different devices and loads the wrong firmware to the wrong device. With that, I would like to end this part of the presentation and just really say as a last word, this is just really one of the little tiny bits of all the testing that we are doing on 447. And but one of the, from all the tests that are 447 specific, I think this has the biggest value to the entire CANopen community, because the entire concept can really be used independently of the application profile. With that, I end my presentation. Thank you.
Thank you, Bernhard and Olaf, for this interesting thing which we can adapt for other application fields. Those details maybe for police, taxi and other applications, yeah, that will go to another conference maybe, where only policemen and only taxi drivers. I don't think that taxi drivers and policemen will have the same conference. Okay, doesn't matter. Are there questions from the audience? Could you use the microphone? Just say company and name and yeah.
Okay, I'm Uwe Koppe from Microcontrol. My question is, we were talking about reinventing the wheel. What is the idea for taking XDCF as a new thing? Because we have something like CIA 309, that means we can run commands via Ethernet or via Modbus. There is something already existing. Is that a new idea? Is there something where we could say, where you could say 309 is not sufficient for what you were doing?
The question is thank you, it's easy to answer. We are, of course, customer driven. We don't reinvent the wheel just because it's fun. And the hardware platform this had to work on has no Ethernet and is a limited microcontroller by itself. And it had already the CDCF player integrated. So from all the options we could give our customers, that was the least expensive one. Guess which one they took?
Are there other questions? Okay. No questions more. Thank you for your presentation. And if there are additional questions coming up, they will be available, I think, today and tomorrow on the fairground.